hello. Hi. All right. Hey, everyone. Really excited to be here. It's been quite a long week. Hopefully, everyone here is ready to learn a little bit about ZK and a little bit about privacy. My name is Kenny, and I'll be the moderator today. I'm the co-founder of a project called Manta Network. We are an EVM-based layer 2 that offers ZK enablement on the application layer, so people can easily deploy ZK-enabled applications through our SDK using just Solidity. And I'll pass the mic over to Jason from Ezekiel, EZKL.
Yeah, thank you, Kenny. So yeah, I'm co-founder CEO of Ezekiel. Ezekiel is a compiler or an engine that lets you turn AI models, Python or general Python code into a proving verifier pair and verify on Ethereum.
Oh, hey everyone, I'm Thiago. I'm the face behind the bear. I'm a research engineer at Herodotus. At Herodotus, we use storage proofs to enable cross-chain data access so that we can prove a certain piece of state, a certain piece of storage from one chain to another. And also, we allow you to do this in a historical way, so you can prove any piece of data from the current block all the way up to the Genesis block.
All right. Hi everyone, I'm Yannick. I'm a co-founder and cryptographer at Elusive. And with Elusive, we are building an encryption layer that spreads across multiple L1s and L2s, allowing users to encrypt their transactions to gain privacy together with decentralized compliance.
Nice, thank you. So we've got quite a diverse group here, right? We've got AI, storage, and encryption for transactions. And so we'd like to just kind of start off understanding a little bit like, what role does ZK play into this like grander value proposition that you guys are actually delivering?
So for me, I think ZK, also from Vitalik, right, is one of the transformative technologies, sort of the next iteration. I think it's going to be as important or more important in blockchain. I think it's and the real win is when you combine the two technologies. I think ZK by itself would actually not be that interesting. Blockchain by itself is fantastic, but very limited in capacity. I think combining the two things is going to result in a kind of a new world of possible applications. I often say I think we're going to get to a point where we have billions of proofs which per blockchain transaction. And I think that's what's going to give us the scalability we need to kind of realize the apps that we imagine would run on blockchain, but we just don't have the computational capacity for.
Yeah, so for us, we use ZK mostly because the computations we perform on chain are extremely complex to the point where they wouldn't even fit on chain normally. So the way that we are able to prove storage is by proving the cryptographic link between blocks. So as I would assume most of you know, blocks and blockchains are linked through each other, right? So each block saves the parent hash of the previous block. And so just by having one block, you can go all the way up to the Genesis. And so let's say right now we are at around block 18 million on Ethereum. We just passed through it last week. And if I want to access certain information from the Genesis block, it will require me to prove 18 million blocks. And this is 18 million hashes. And this is quite an expensive computation. And so we use ZK mostly for this to offload some computation that would normally be done on-chain. We do it off-chain, and we just verify the proof instead. So, yeah.
Yeah, for us, or for me personally, I have a quite similar view than Jason. We have blockchains that, for example, by default are public, and using zero-knowledge proofs, we can add privacy to those blockchains. So that's what we mostly use zero-knowledge proofs for, to prove that a user in the past has deposited funds or has spending authority over certain assets on the blockchain. But on the same time, we also use zero-knowledge proofs to prove that users are, under some definition, non-illicit actors, that certain funds come from a certain subset of sources. So applications of zero-knowledge proofs, I think, really enhance blockchains.
Got it. And so you guys are all, leveraging ZK or Snarks in some manner. And but one of the things in this space right now is that there's so much innovation going on, right? Like, who knows what proving systems even look like 3 years from now, 5 years from now? And so, like, do you guys see yourself using the same sort of systems in place today for whatever sort of proofs that you're generating? Are you guys looking at like flexible options to be kind of more plug and play modular? Like, what's your approach to this long-term sustainability on the ZK side for, your projects?
Yeah, so of course, when you're trying to run something, a company based on ZK or production stuff on ZK, this is a constant question, right? You just like you can date sort of Web2 startups by what database they use, right? Like if they used Mongo, so you launched in this period, or
you use COBOL, your finance.
Yeah, right. So I think that probably to an extent you'll sometimes be able to date ZK startups based on what their proving stack is. However, I think we're blessed with a period where there is just incredible innovation in ZK through at a theoretical level and the practical level. And for us, we sort of view ourselves as a consumer of the research. So as the time that it kind of gets close enough to production, then we think about moving it into something that we'd actually use. And we sort of have the luxury of academics and these days venture capital firms are funding a lot of really great research, and we can kind of just sit back and wait for the ones that fix the bottlenecks that we need when we need them. I think it's important for everyone not to get too distracted by all the shiny new papers coming out. They're wonderful. I used to be a math professor, love reading them, but if you constantly try to change your proof stack, you'll never get to production.
Yeah, I mean, I definitely agree. It's insane, like the amount of things that have been coming out on the ZK space these days. We have folding schemes every new week. We have there was recently a big discussion between like polynomial commitment schemes. People were comparing Fry and KZG. We have lookup arguments now with Lasso and Jolt that are proven to be apparently very efficient. So yeah, I mean, the amount of papers and research coming out is very hard to keep up with, to be honest. Yeah, at Herodotus, we mostly use Starks and Cairo. So yeah, we don't have as much of a problem as like most of the innovations coming out seem to be on the Snark space. But I actually expect them to start happening on the Stark space anytime sooner too. But yeah, like my advice for people building with ZK is don't try like every new paper. Like don't try to implement every new paper. Don't try to experiment with every new shiny new folding scheme. Yeah, try to stick to something that you personally like are a fan of. Try to do your research, and also sometimes I have a feeling that it's a bit overrated for people to always like. I think like choosing the right proving system, like the exact perfect, it's a bit overrated. I feel like it's a very common question among ZK teams to ask each other. Oh, which proving system are you using? And at the end of the day, let's be realistic. Most of users don't really care about that. Of course, it's very important to choose your proving system more tailored to the solution, to the problem you're solving. But at the end of the day, you are building for users, I expect, right? And so, yeah, I think it's important to keep a focus on that.
Yeah, I agree. So having your SaaS startup in the past, for example, you wouldn't go out and sell to users, hey, we're using this database technology, we use this network communication stack. So for us, we mainly utilize Snarks, but I think at some point you need to stick to some technology and maybe a few years down the line reevaluate and then look for new proving systems. So especially when keeping in mind that those innovations that we see are scalability innovations mostly, and so if you've reached some absolute point of efficiency, you might not need to have 1 millisecond improved proving for all applications. So I think, yeah, as you said, in the ZK space, we tend to thoroughly talk about all new innovations and papers, but at the end of the day, everything is a zero knowledge proof, and I think we can stick to those general terms and should stick to those general terms because everything else just, yeah, doesn't help us.
Yeah, I'm very much looking forward to the day that we don't have to worry so much about which new proving system's coming out the next day and if it'll make us extremely obsolete. But there's the one side on the provers, right? But then the proof generation and the verification, that's extremely computationally intensive. I'm not exactly sure how sensitive you guys are for that, but I do assume that at the end of the day, it really impacts the user experience. And so I know another sort of hot topic in ZK is hardware acceleration, right? And so would love to understand a little bit more about does your project really depend on, or hopefully can leverage hardware acceleration, or are you looking at other paths for optimization and that better user experience?
Yeah, so for us, we're based right now in Halo 2 with KZG commitments. There is a lot of evidence that hardware acceleration is going to help that. We talked to some of the hardware acceleration companies. Right now, we just use CPU proving. And at some point, probably in the next few months, we'll throw in some GPU proving. I sort of view it as I get a one-time, maybe 10, 20 times speed up, and maybe another 10 from FPGAs or something. And it's great, but hopefully not something that we depend on. The acceleration from algorithms is, I think, going to be the major driving factor. But that said, I really encourage everyone to work on hardware because it will reduce our costs, right? So if we have really good hardware, then and especially I would really like the phone manufacturers. So for all of you in the audience who work for Apple and Samsung, please put proving chips into your phones so that we can do more privacy-preserving device-side stuff. Yeah.
Here I think it's a similar situation. We're also not using currently hardware acceleration. We do everything on the CPU. As we're speaking, we have a huge machine running with 18 cores, proving a bunch of blocks, which is pretty exciting. But yeah, we're talking with a lot of hardware acceleration teams. Also, it seems that a lot of new teams are coming up in this industry, which is quite exciting. It's something that we definitely plan on using later on. But I feel like before we look into hardware acceleration, and I feel this is true for most teams, we probably want to be a bit more stable and figure out our things a bit more and be a bit more production ready, then we can look into this kind of thing.
Yeah, I guess same for us. Since those proofs really need to be generated on any device, you cannot really rely on hardware acceleration. It's a bit different for you guys, I assume, when you need to prove some specific on-chain state. But for us, it's really allowing the individual user on their smartphone, in their web browser, to generate a zero-knowledge proof. And I guess the approach that we take is, or the benefit that we have is that the proofs that we need to be generated constraint-wise are quite limited. So we don't need to worry about those things as much as you guys, since we try to keep it small, keep it on the user end, and not require a big cluster to permanently generate zero-knowledge proofs.
Yeah, there's interesting things that I want to make about hardware acceleration. I went to a panel in Houston that I participated in, where the audience was all miners, right, Bitcoin miners, and for those folks, they don't really care what the algorithm is. They don't care what they're literally the guys that plug in they plug in the box, they cool the box,
they make money.
How to get cheap power? Yeah, how to get cheap power to the box, right? How do I efficiently take a container and use Crusoe energy or whatever? Like, how do I efficiently use excess capacity for the grid? And they think in terms of thermal envelope, power envelope, right? And not in terms of what algorithm, right? So the place we're at in ZK right now with really rapid transitions and changes, I can't tell those guys, this is how much power you need, or you can't even tell them how much RAM they need. I can't even tell them whether they should have a lot of small cores or a few fast cores. So I think as the industry matures and we get to a point where the workloads are more regular and kind of more modular, containerized, then we're going to see a lot more innovation in the hardware side and expansion in mining.
Got it. Yeah, I think the history of these sort of hardware acceleration solutions, or even quote unquote hardware acceleration, is just, it kind of mimics very much Bitcoin, right? Like you got CPU mining, then you got GPU mining, now we've got specialized hardware, now we got proof markets so that you can zero sum and economically benefit from all of it. And so yeah, really excited to see, or I don't know if excited or not, maybe it's just take up more energy than Bitcoin in the future, who knows. But another really interesting question, and this is something that I borrowed from my buddy Gary. Is well, at the end of the day, your goal is to deliver some value to some user, whether it's other businesses, other individuals. And so the question is, like, why are you taking this approach? Why can't it be something that is achievable through a more Web2 centralized approach?
Yeah, happy to.
I'm going really off
to
script.
I think at the end of the day, trustlessness really is the key, right? If I'm a company that, for example, wants to train AI models, I could just rent out some Web2 server and have my training be happening there. But I would require trust in that third-party provider to perform the actual computations they tell me they're executing. Zero-knowledge proofs allow us to have verifiable computation. So in that sense, we can achieve trustlessness. And with the added benefit of blockchains, another missing link, I guess, from zero-knowledge proofs can be added, which is context. So the zero-knowledge proof simply exists and allows you to prove the truth of some statement or the knowledge of some statement. But there's no shared state that everyone agrees on is the correct state. And plugging zero-knowledge proofs with their trustlessness and some trustless state into each other allows for completely new applications, I guess, yeah.
Yeah, I mean, for us, we don't really have a Web2 way of doing things. Our whole product is about proving blocks on chain, right? So we're natively blockchain in the first place. But maybe I can take this question as, why are we like choosing to use ZK and like choosing a more novel approach to solving this problem? Because there's been previous attempts of solving this problem, right? And what we noticed is that before, a lot of people trying to solve interoperability or historical data access, they either introduced some trust assumptions or some scalability limits. So it probably wouldn't scale forever, or you just had a multisig in the middle, and some of them still claim to be trustless. But yeah, so that's the need we saw. We saw clearly demand in the market for cross-chain data access and historical data access. And yeah, existing solutions were just not there yet because of the problems I just described. And so that's why Herdota started. And yeah, that's why we rely on like a more novel approach and why we use ZK to solve this problem, because it's the only way of solving it, remaining trustless and scalable.
Yeah, so for me, okay, let's go back to the beginning in 2009, Bitcoin again, right? So what did Bitcoin do? I think of it as an innovation in applied cryptography that allowed us to solve a collective action problem, and that no government, no centralized entity had previously been able to solve, which is a very simple thing that humans want. Can I have a non-inflationary currency? Can I have a way to have money that doesn't automatically...
That's what I've wanted for so long.
Yeah. Doesn't automatically kind of be debased by whatever the centralized power is, right? Okay, so that was a great innovation. In some sense, it was a simple one, but I think that the core thing that's happening here is that applied cryptography in general lets us change the space of collective action problems that we can solve. It expands the frontier of, Pareto frontier of things that we can do. And so in order to change social equilibria and solve collective action problems like that, by their very nature, that has to be a decentralized thing. Because otherwise it's not really I mean, I guess you can solve collective action problems by having a central dictator, sure. But that has other bad effects.
Singapore.
Right? Sometimes it has bad effects.
Or is
undesirable. But, so that's to me the appeal, and the reason we have to do it in a decentralized way, because it's kind of the core thing that we're doing is really not technical. It's like a social, political, economic phenomenon.
Got it. Okay, thank you. And so we talked a lot about the technology stack, where you guys are thinking about your products 3 to 5 years from now, right? But like, what about the actual users? Who are you trying to address, right? Like, if you were to tell the audience, like, this is the killer use case, right? Like, what is it when it comes to each of your products and services?
Yeah, so for us, we live very far down in the stack. This business that works without kind of, even if I didn't directly touch the chain, we're sort of producing a product that lets you make proofs. We maybe do some of those proofs for you, help you manage the pipelines, and it's kind of up to you what to do with it. So, our natural customer is kind of another business or protocol or someone that wants to plug zero-knowledge proofs into what they're doing in an easy way. And I like to stay away from applications because I think I'm not very smart about them. So I prefer to think about it as like, I'm producing this tool. I'm going to give you some, big picture speak like I was just giving about, what are the cool things we could do or what aims should we have. But I'd really rather that someone who has that kind of talent for growth and talent for end user experience decide what that is.
Yeah, so for us, we are a developer-targeted product, so our users are developers. Probably some of you in this room, if you're interested in building any app that makes use of historical data access or cross-chain data access, please come talk with me after this panel. Yeah, so as I said before, developers already have some solutions for this, but the solutions just don't work as expected. So we see a lot of existing teams already that has some product before that want to migrate to a more secure and a more scalable solution coming approaches. So this is a very common thing that we see. Also because storage proofs just also unlock the time dimension. It's quite a new thing. So now we can have new primitives that we just couldn't have before. Like we can compute TWAPs on chain, we can compute volatility on chain, and before we had to rely on semi-trusted parties to access this sort of data, right? Like oracles and so we just unlocked a whole new bunch of applications that was just not possible before. So yeah, I would say that most of our users are either previous DApp developers that now see a need to migrate their infrastructure to a more secure and scalable protocol, or completely new ideas that come out of these new use cases.
Yeah, so for us, offering this encryption technology, adding privacy to the blockchains, of course, addresses every single blockchain user, be it the individual that wants to remain private, or be it institutions or companies requiring confidentiality in their on-chain activities. As secondary, I guess, target group, we of course also have developers. So offering developers to add privacy to their existing applications where the users actually add, I think is important, simply because talking about ZK, talking about the need of privacy is very exhausting and is not something that at the end of the day you might want to do to the individual. So you need developers to actually integrate those technologies so the individual doesn't have to worry about data protection anymore. Yeah.
Yeah, I'd like to comment on this. I think that's something very interesting that we're seeing in the use cases of ZK. I feel like in the early days of ZK, it was very experimental, very theoretical, and it was mostly targeted at very low-level developers or researchers. But I feel like now with time, we're seeing ZK finally going higher in the stack, and actually normal users actually using ZK without even knowing they're using ZK, right? And I think this will be the end game for ZK, is that to have millions of users, perhaps billions, using ZK without actually realizing they're using. And I think we're going in the right direction. I still feel like we have a long way to go, but we're definitely going well. So yeah, I just wanted to share this.
How many of you guys have used the ZK-enabled application before? Wow, we're getting there. Nice. All right, cool. Well, how many of those applications were not Tornado Cash? All right, still a while to go. Okay, cool. Yeah, so got some amazing questions actually on the script. I don't know if you guys review this or not, but I think this kind of flows right into what you guys are talking about with usage and on the user side for the privacy especially. Would love to understand, it's a little tricky, but when it comes to thinking about a million users, a billion users, right, a trillion users, get those aliens in, those ones recently discovered in Mexico, but just getting those in, right? How do you think inevitably enterprise has to play some sort of role in this, right? And so from your perspective, right, it doesn't even have to be what you guys are building, but just broadly, what role does ZK play in this sort of enterprise adoption?
Yeah, so we absolutely are building for enterprise, but probably not today, soon. And I think sooner than we initially expected, because ZK has moved even faster than anyone expected. I think the thesis we had, and a lot of people have, is that in the beginning, for the first few years, it's really blockchain is the only place that it's going to apply. And the reason for that is that blockchain has this enormous asymmetry between a EVM, let's say, if we're for Ethereum, this extremely important, extremely valuable, but extremely weak computer, and an extremely fast, by comparison, server or even laptop, right? Your laptop is so much faster than Ethereum. And so this massive asymmetry in compute gave us the headroom to have ridiculously inefficient proofs. And as those numbers, that multiplier gets down, it starts to be something that is worth it for enterprise. I think the biggest challenge right now is just explaining what it is. So the other reason that crypto is the right space, blockchain is the right space to start this work in, is because we have this intuitive understanding of asymmetric cryptography. We all know what an ECDSA signature is. We understand its properties. We understand there's a chance that I can mash my keyboard and guess Satoshi's keys, but we're not really worried about that as a practical security concern. So when we say it's a probabilistic proof, it doesn't keep us up at night. We can say, okay, we're going to produce this proof. It'll have similar characteristics, similar security characteristics to that. People are okay with that, right? Programmable signature is what a ZK is. But explaining that to a general audience, even very sophisticated, when they're not used to using digital signatures every day, is just challenging. And so I think we're still struggling with what are the right abstractions, or what is the right way to explain the value add of ZK to a general enterprise audience. And as we refine our speech, and as we go to these guys and they slam the door and say, we don't need that, and by the way, you're tainted by crypto or whatever, we will gradually figure out how to tell that story.
Yeah, 100% agree with this point. I also feel like ZK is not yet at a point where it can be adopted by enterprise. I think now the main use case for ZK is definitely on blockchains, from what we see. Due to the decentralized nature of blockchains, it makes it a perfect environment to verify proofs, right? But yeah, I expect as the ZK tech moves more forward, to start seeing other use cases. We're starting to talk about client-side proving and client-side verification. Hardware acceleration is playing a big part in these too. And so yeah, I just think that the ZK ecosystem needs to mature a bit more.
Yeah, I agree. Having those direct enterprise use cases might still require some time. However, ZK enables enterprises to use blockchains at this moment, right now, simply because ZK improves security, ZK increases scalability, and also increases efficiency, bringing down costs. So I think thanks to ZK, blockchain actually is an enterprise use case as of now. Yeah.
Yeah, and also something that's important to mention is that all the cryptographic standards are now widely used nowadays, like RSA, Diffie-Hellman. They were not adopted like shortly after they were created, right? Things take time to mature. We need standards, we need RFCs, and so I think it's pretty much like it will happen the same with ZK. We've seen it before. The story repeats itself. So yeah, I think that's what we're going to see.
Yeah, those standardizations, I think this is one of the selling points, or one of the things we can all congratulate ourselves on in being in this field is this is the dark forest, right? This is like the most hostile cybersecurity environment in the world that we've all grown up in, and we're used to being, constantly attacked and SIM swapped.
Thanks, North Korea.
And everything, right? And so, in some sense, if this works, if we survive, right, we're going to come out to sell to enterprise, and the stuff we have will just be so much tougher, so much more battle tested that other vendors just won't be able to compete. I think that's the hope, right? That all this pain that we're going through to secure this stuff will pay off in terms of just having a much more secure infrastructure for everyone.
Cool, yeah. So I mean, talking about like enterprise adoption, right? Like, and thinking about just this general adoption. There's always sort of a dark side to this, right? Like, I'm sure that for each use case here, whether it's on the storage side, right? I'm imagining there can be very bad things on the storage side. Privacy for transactions, tornado cash, right? So is this something that keeps you guys up at night, right? Like in terms of the user base, in terms of who gets to use it, in terms of do you think enterprise adoption really could occur, for example, if you're mixing everything together in that sort of same environment, right? Like, what are your perspectives on that?
I can only speak for us, and I think that's that's the perfect thing for me to speak about, because that's what I do on, or what we do on a day-to-day basis. Try to find a solution to not have to worry about those things. And what we found is that you basically have two aspects to that. You have on the one side the regulatory compliance requirements, and on the other side, as you described, you have unethical actors in your ecosystems that in total harm our crypto ecosystem. So you will have the second aspect of some sort of need for self-regulation in this ecosystem, which can actually be isolated from regulatory requirements. I personally can say that I think we don't have to worry so much about those issues, because we actually have built a solution for that. So, and it's less about people using those tools and ZK being bad and cryptography allowing illicit activities. For us, it's really ZK enables both those activities, but also allows us to solve those problems. So we don't use ZK to provide privacy and then take some traditional approach to compliance, but instead we use ZK, and in broader terms MPC, which can also be seen as ZK, to solve this. So I think to those issues, mostly the answer can be we need to use more cryptography, and we need to use more distributed systems technology, because at the end of the day, those issues, again, are just issues, just as having those private ledgers that are being controlled by centralized entities. Same thing applies for compliance and illicit activities. So I think that would be my answer.
Yeah, so for us at Herodotus, we don't make use of privacy in ZK, right? So right now ZK has two main use cases, privacy and scalability. We are more focused on the scalability aspect than the privacy one. And yeah, something that's very important in our culture is simplicity. I feel like now in ZK these days, everything is so complex. We have like, again, all the proving systems that we talked about, all the primitives we talked about, everything tends to complexity, right? Like it's how the universe works, everything tends to chaos. And I think something that we've learned before in the past with tons of attacks, and even with Bitcoin itself, we learned that simplicity is key, right? And when designing cryptographic systems, I'd say it's very important to be as simple as possible, as exploits can occur where and when we least expect them, right? And so this is a big part of our ethos, is simplicity. Sometimes it's not easy to build complex systems with simple primitives. That's what we try to do to the best of our ability. But yeah, I hope that most of the space follows along this way. Unfortunately, I feel like some people like the complexity, and yeah, I mean, of course, it's fun to explore like more complex systems and discover more complex primitives. But at the end of the day, I still think that simplicity will always be the key.
A couple of things. One is interesting to connect the question of privacy with enterprise usage, right? So financial privacy is at best controversial. Okay, so I mean, I'm a fan of it. I think it's important because it backs up human rights, but it's controversial. However, privacy in the context of enterprise has a very different meaning, because that privacy may actually be a compliance requirement, or it might be protecting trade secrets, or just the expectations that companies have that not all their data is revealed to their competitors, right? So I think privacy in the corporate context or enterprise context is much more palatable to every regulator, and maybe even required. The other sort of dark side issue that I think is important to bring up is one that Madars, you probably know Madars from MIT, always asks me.
We were both at the DCI, yeah.
Yeah, okay, right. So Madars, he says, what are you doing? Like proving these properties, saying, oh, I can prove that I'm not on a sanctioned list or whatever. Because if you do this too much, you kind of get to a point where the government can require you always to prove that you're innocent, right? That every time they can look deeper and deeper into what you're doing, it's like, you have to scan your phone and prove there's no bad images on your phone, and you have to scan your email, and so like, because it's privacy preserving, in some sense it might empower people to be more intrusive. And so I think we ought to think about how to prevent that kind of thing from happening. Empowering more intrusive surveillance, just because we can do it in a theoretically privacy preserving way, or in the sense of simplifying it to a property being there or being not. I don't have an answer for that, but I think it's important that we worry about it.
Yeah, I agree. So, what my view on this is really that we're at a sort of crossroads where we actually need to think about what technologies do we want to push into the mainstream, and if we were to push Zcash into the mainstream and force everyone to use that, I feel like the governments and regulators would force us to get down a different path, which would lead us to a fully centralized financial system without any privacy. So we need to be very cautious about what we actually heavily push for. So the approach that we've been taking is finding some place in between that works for all parties involved, without allowing any centralized regulator to just force their will on the users, while on the other side not allowing any illicit actors to force their will on all the other users by misusing the privacy that everybody gains from collectively wanting to be private. Yeah.
And it's a good question is like, would you prefer to have a fully decentralized payment system that has no privacy? Or would you prefer to have a fully centralized system like the ones we have today with some form of pseudo-privacy? Like, it's a pretty tough trade-off there.
Yeah, I think that the question is, do you want asset ownership or do you want data ownership, right? I think that would be the differentiation. I think I can't give an answer to that. For me, privacy is very important, but I don't think we could sacrifice our actual asset ownership and decentralized systems for that.
Yeah, I think that's a very interesting point. I think recently we've started to see kind of a new primitive where, hey, it's actually okay to have centralized systems as long as you can verify them, right? We're seeing this with rollups, where you have centralized provers, centralized sequencers. Of course, now everybody's trying to decentralize provers and sequencers, but I think it's a very hard problem to solve, and that's what blockchains are about, right? Solving the trilemma. It's it's what we are all doing here. So yeah, I'd say privacy is very important, but yeah. In the ideal world, we'll have both, but yeah, I still don't have the answer for this. We're getting there at some point.
So I got married about like a month ago, and this is actually a story about privacy. Thank you very much. Wow, you guys are paying attention. Great. And in that month, you know, we decided to create a joint bank account, and I realized now that someone's monitoring my transactions, like, I don't order as much on Amazon anymore, you know? Like, you never realize this, but you know, the monitoring really alters your behavior. Yeah, so anyway, for you guys, what keeps you up at night? Like, you guys are obviously building things that are not just very complicated to productize in the market right now, in the market conditions, right? Scaling out that productization is very important, but also very hard. And then we've got to deal with compliance and regulation, right? But like, what do you feel like you're prioritizing right now in terms of like the problems that you're facing? You can get philosophical if you want.
Yeah. So what are the problems we're facing? I mean, it's been very much at this stage kind of a grind of iteration, right? We talk to users, we try to fix the things that are going wrong or that they aren't happy about, and just constantly improve. But I think one of the big picture things that I'm worried about for us and for the space is, can we articulate what we're doing, you know, in a way that doesn't require 10 PhDs, right? And another way to say that is that we have to come up with good abstractions, right? So we started with a signature abstraction.
3 PhDs, so I don't know if I can understand you right now.
We started with a signature abstraction, which is great. People can program with signatures. You know, you can create certificate authorities. You can do all these nice complex things. It's a simple primitive. People understand it. And then we try to hand them a fully fledged, here, now you can do anything you want in ZK. And it's like someone asks for furniture and you just hand them a giant block of wood and a saw and you say, hey, you can build any furniture you want. Isn't this great? Pay me money, And they're like, no, like I hired you because
it's like hot pot, you know?
Yeah, right? So, our job is not to hand them the block. Like we have to make it into something useful, a table, a chair, you know. And I think as an industry, we figured out how to get a lot of power to create interesting things, but we haven't really figured out what are the right abstractions that are kind of tasteful and empowering, that let people build quickly. So that, yeah, we're just struggling to figure out what those are.
Yeah, for me, what keeps me up at night? Yeah, I'd say there's not a lot of things, fortunately. Yeah, I mean, we're building a complex system, and this goes back to what I said before about simplicity. We have a lot of moving components. Most of them are relatively simple, but we have a lot of components. And when you have a system with a lot of components, if something breaks, right, if a single component breaks, you break the whole thing. And yeah, and I think this is happening in also like in more like theoretical ZK, like proving systems that have a lot of components. Like we can fail on the polynomial commitment scheme. We can fail on the arithmetization level, even on the front end itself. Like there's a lot of like failing points possible in the ZK industry in general, I feel like. So even if we manage to make each component very, very simple, we still have a lot of components and we still have a lot of possible points where we can fail. So yeah, this is a concern that I have is, okay, what if like some of these have very simple points, yeah, actually it doesn't work as we expect, or if it's proven wrong.
Yeah, what's actually keeping me up at night, I think, goes into Jason's direction of really thinking about, okay, we built this amazing tech in this space, we have great tools, but how can we actually move those tools closer to the user and abstract them away so that the user doesn't need to know that they're using ZK, doesn't need to know that they're actually remaining private on the blockchain, because at the end of the day, users don't care about that stuff. Users only care about usability. And many of the ZK applications in the past have been suffering from this aspect. Then leading users to pick centralized apps because they don't have this issue, and the user just needs a little bit of trust and instead can use the easier and cheaper to use centralized apps. So I think that's what really is keeping us up at night, improving the technology, abstracting away everything, being integrated at the fingertips of the user, so the user doesn't have to worry about privacy, I guess. Yeah.
All right, cool. Well, now all of you guys are ZK experts, so go out there and build.